Hello students, today we are going to conduct a practical of strength of materials which is compression test on timber. So for that we need a timber specimen which is normally you know by the name T-Cood. So the title of the experiment is compression test on timber and the main object is to determine the compressive strength under static compressive load on a given timber specimen in two cases, when the load is applied parallel to the grains and when the load is applied perpendicular to the grains. The equipment we are going to use for testing is compression testing machine which is having a capacity of 2000 kN means 200 tons, and we are going to keep the specimen between the plates and apply the compressive load. But before that we need to understand what is the basic concept or theory behind this. So this is a timber specimen. In this timber specimen there are grains or fibers which are connected together to form this specimen. So these individual fibers like hairs are responsible for taking the load as a specimen or as a material which is used in construction as a timber for supporting, centering or other flooring works. So it should withstand the load which is imposed on it. So these fibers act as a column when the load is applied parallel to the grains, and when the load is applied perpendicular to the grains, it also acts as a fiber but it will take less load. So we will practically prove that whether this concept proves to be as it is said as per the IS code. Now the IS which we are going to use is IS 1308, which is for testing compression test on small timber specimen. So before starting the practical, what is the procedure is you have to measure the specimen with the help of tape, or you can measure using vernier. Now see, the length is around 49 mm and take other dimensions which is width or height which is also 49 mm. So this is a square specimen having dimensions length as 49 mm and width as 49 mm. So firstly we will apply the load in parallel to grains, means in the direction of grains. Now for that purpose I will mark the direction, means these are the grains which we can see, these are the vertical fibers, and we are going to apply the load in the direction of these grains. So I will mark with a pen or a marker that we are going to apply the load in this vertical direction. Now I will start with the compression testing machine. I will fix the specimen, apply the load, and we will see at how much load it fails or breaks. Fix the specimen firmly into the compression testing machine and start the instrument. Now we will apply the load after knocking this wall. Slightly move this load application wall. You will see the load is being applied on this timber specimen. You have to check that whether the specimen is fixed firmly. More than 100 kN load is applied on the specimen. You have to see from all the directions whether the load is applied with the specimen is filled. Now you can see here the load is around 159.5 kN. Now we check whether the specimen is filled or not. Yes, the specimen has crushed at a load of 139.5 kN. So we will stop application of load. So the load at which the specimen has failed is 139.5 kN, means approx 140 kN. We will remove the specimen. And see, this specimen has filled, and along the grain, parallel to grains means the direction of load is parallel to these fibers. So the specimen is filled. Now we take the other specimen having same dimensions 49 mm into 49 mm, and here we will apply the loads perpendicular. Now see, the grains are like this. Now in this case we will apply the load perpendicular to the grains, means grains are in one direction, load will be applied at 90 degree to this direction. Now again we fix the specimen into this machine and see at what load the specimen fails. Tight the specimen using both the plates. Now start with the compression testing machine. Now the load has started applying on the specimen. We have to see whether in this case the load value crosses the earlier value, which was 140 kN, or it is below that value. We have to keep on checking whether the load is being applied in all directions. Specimen has failed at a value of around 53 kN. So we stop the machine, lose the pressure in its valve, and remove the specimen. You can see the specimen has crushed. So in this case, the load is around 53 kN for load perpendicular to the grains, and in the earlier case it was 139.1 kN, means 140 kN approximately. So almost 10 times more load than this load applied perpendicular to the grains. So the basic concept of theory behind this is that whenever the load is applied perpendicular to the grains, even if single fiber breaks, the whole specimen will break immediately. So it takes less load. So this is the reason why this specimen fails at a lesser load. But for when the load is applied perpendicular to the grains, each vertical fiber, which is like a hair, will act as a column, and even if one fiber fails, rest of the fibers will keep on carrying the load, and then ultimately the specimen will fail after some time. So it takes more load, which is 140 kN. So how to calculate the compressive strength? By using these values, we can use the formula compressive strength is equal to failure load divided by cross section area. So for parallel to grains, the area is 49 mm into 49 mm, and load is 139.1 kN. And for perpendicular to grains, area again it is same, 49 into 49 mm, and load is 53 kN. So you divide this, you get the value in kilonewton per mm square or Newton per mm square. So this is the experiment of compression test on timber. Thank you.